right, we're talking about the probability of Walter making each number of free throws, and we've built up an idea that there is a combination that you can use, like 5 choose 2. You can use that combination to predict how many times he's going to shoot a certain number of free throws and make a certain number of free throws. And then you can figure out the probability of it all. But I would absolutely be 100% happy if you could understand and follow along with why there's a formula right here that we can use, because it's a really good one. Let's build this whole thing up though. If he's going to shoot one free throw and not make it, then that's going to be multiplied by the probability of him making it. No, it's not going to happen. Times the probability of him missing one shot. So the 0 is he made it 0 times, and the 1 is he made his one shot. No, he missed. The 1 is that he missed his one shot. And then the combination is that he shot one shot and missed. On the flip side, he shot one shot and made it. So it's the probability that he made it to the first power times the probability that he missed it to the 0 power. And so every time that we go down Pascal's triangle, right, from the last episode, we're going to change the exponent to match this combination row. So shooting 2 free throws, making no free throws, the probability of a make and the probability of a miss stay the same. It's 2 free throws, making no free throws. So a probability of a make, times the probability of a miss, twice to the power of 2. And then this calculation, it's just a calculator calculation from now on. I'm not even concerned with the number because somewhere in our previous, pages, we did the calculation and we don't need to go back over that again. You have a calculator. Let's carry the pattern though. So 2 choose 1, make to the 1 power, miss to the 1 power. Both of these add up to 2. He shot 2 free throws. Both of these add up to 2. He shot 2 free throws. So pay attention to your exponents. Shooting 2, making 2, the probability of a make happened twice. The probability of a miss never happened, so that's a 0. And 2 plus 0, exponent addition, is 2 because he shot 2 free throws. Are you seeing the pattern? Are you seeing how things are connected? Let's try it with 3. Shooting 3, making none, then the probability of a make has an exponent of 0 because he never made a shot. The probability of missing gets a 3 because he missed all 3 shots. Making 1 shot. So then the exponent here on the make is a 1. And then up here, the probability of missing, he missed twice out of 3 attempts. So then this is a 2. There's another way to get to that 2 though. You can just do 3 minus 1. Formula. Making 2 shots out of shooting 3. So 3 choose 2. On the probability of a make, 2. On the probability of a miss, 1, which is the answer of 3 minus 2. So we're going to get to a formula here in a second. Pay attention to right there. This 1 and this 2, you add them to get a 3. But how do you get a 1? You 3 minus 2 it. 3 subtracted by 2. What if he shoots 3 free throws, he makes 3 free throws, then it's the probability of making to the 3rd power. How do you calculate missing then? Because probability of missing is not the probability of making, and if he makes 2 out of 3, he's going to miss 1 subtracted by 2 out of 3. This calculation right here, I'm going to put that on the bottom. Note 1/3 is 1 minus 2/3. And the 1 can be rewritten as a fraction of 3 over 3, and 3 minus 2 is 1. So this has an exponent of 0 to finish this entire out. What's the formula then? Let me develop it slowly. The first part, combinations. If he's going to shoot in shots, and we want to know of those shots, how many is he going to make? Then it will be the probability of making to the r power. Okay? So this r is that exponent. Notice this 0 is that 0. This 1 is that 1. This 0 is that 0. This 1 is that 1. So that's the structure. The probability of A is 2/3. So there's a 2/3 all the way down. The next one's a little weird. Now they use the probability of not A, and the little squiggle means not. There are a couple other ways. I've used a C in these lessons. I've also seen like this symbol, but we mean not that. The way to calculate this is to do 100% minus the probability of A. Because if A is a positive and not A is a negative, then together all of them add up to 100%. So 1 take away the probability of A is another way to get not probability of A. 1 take away probability of A. Close parentheses. This entire fraction is 2/3, or 1/3, and I said that down here. So then this 1 minus that probability is the 1/3 that it's calculating. How do we get a 0 here? How do we get a 2 here? How do we get a 1 here? How do we get a 0? So how does this 1/3, what is the exponent on the 1/3? Where does that come from? Subtraction? Subtraction. 1 take away 0 is 1. 1 take away 1 is 0. This number subtracted by this number is this answer, this exponent. 2 subtracted by 1 is 1. 2 subtracted by 2 is 0. So in parentheses, n minus r. I told you we'd get to a formula. I told you we would find a formula for calculating the probability of a combination of events happening when the trials are independent. I told you we would find some formula. I didn't say it'd be nice, but I did say it'd be complete. This is a complete formula for finding the probability of making a certain number of things happen, given you know the probability, you know how many attempts are taken, and you know that you want like a success rate of 5 or 2 or whatever your of 5, 2 of them are correct. That's our formula. Get a little more highlight on there because it extended outside the box because there's just so much to write. Do you understand that formula? If not, go back and watch the video or talk to me about it. You need to know this structure, and we're going to practice it in the next section of videos. In fact, I think I'm going to make a note card of it and have it like ready to flop in front of us every time that we need to do a calculation, like on page 887, the next page in our section of videos. Thank you for watching. This has been page 886, and I'll see you in the next episode.